Hello and welcome to the walking talking topic on constructions and loci. Question number 4 with me, Mr. Barton. Now what a flipping weird question this is to end, but I've got a bit of a soft spot for it because I've not seen anything like this before. So let's have a look. A fishing competition is to be held out at sea in a rectangular area that's 5 kilometres by 4 kilometres and marked out by boys. Safety boats are positioned at 2 different corners, that's going to be important, of the rectangular area marked out by the boys. Each safety boat patrols an area not exceeding 3 kilometres. Consider the options for positioning the 2 safety boats. Decide which of your options is best for positioning them. You must clearly show why your solution is the best option. Right, so we've got ourselves a rectangular area 5 by 4 and we can put these, say, the corners, and each one can patrol an area of 3 kilometres, and essentially we've got to find out which option is going to give us the most coverage. Well, the best bet is let's start drawing and let's have a little mess around with this. So we've got to draw ourselves a rectangle 5 kilometres by 4 kilometres. First, let's get a scale up and let's impress the examiner here. So I'm going to go for a scale, and we can keep life nice and simple here. Let's say 1 kilometre is equal to 1 centimetre. So let's draw ourselves, and I'm going to draw it in the corner because I might have to do a few of these. I'm going to draw myself a 5 by 4 rectangle. Now, it's a bit harsh this, that they haven't actually drawn these rectangles for us, because it's quite hard to actually draw a rectangle. But I'm not going to go into any fancy constructions. I'm going to use a little cheat. I'm going to line my ruler up so that one side is parallel to the paper. And that's going to allow me to draw a nice kind of vertical line. Oh, geez, it would do if I held my ruler down. And I'm going to draw that 5 centimetres down there. Then I'm just going to have to do kind of with the eye here to try and get a 4 centimetre. It's not going to matter too much if I'm a little bit out, but it would be nice to be accurate. So I'm a bit rubbish at my spatial awareness. So let's go for that, and let's go for that. Up to the top there. Tell you what, that's not the worst rectangle I've ever drawn in my life. And I'm just thinking there's going to be a few different options for the position of the boys. They could kind of both be at the bottom there. Both be at the top would be kind of the same as both be at the bottom, so that's not really interesting. They could be diagonally opposite to each other like that, or they could be like that. So I think there's kind of 3 distinct positions. So just to prep for that, I'm going to draw myself 3 rectangles. So again, I'm going to use the side of that to do a 5 centimetre one. And let's go across here for 4 centimetres. You know what, I bet I'm going to run out of flipping room here for this. 4 centimetres. And I'm going to come down here and hope that it's 5. Yeah, I'll tell you what, that's my best one yet. And then I'm going to have to squeeze this one in a bit tighter, I think. 5 centimetres, please fit, please fit. Whew, just 4 centimetres. 4 centimetres. Hopefully 5. That's not bad. Alright, I'll take that. There's my rectangles. Okay, so let's mess around with the position of the boys. Let's first go for this technique when one's there and one's there. As I said, there's no point doing one at the top and one at the top, because that's exactly the same as that flipped around. So next one I'm going to try one there and one there. And again, there's no point doing one there and one there, because that's exactly the same. And finally, I'm going to do the diagonals. And I'm going to see which one of those covers the most area. So these boats can't travel more than an area of 3 kilometres. So on my scale, that's going to be 3 centimetres. So if I set this accurately once, I can just do the same for all of them. So let's have a look here. And I said in the last video that I've never done my compass better than I have been in these videos, and that could well mean I'm going to be absolutely useless here. But let's have a look. So spiky bit on the corner. Oh god, there you go. Spiky bit on the corner. So that sailing boat there, if he lived there, he could cover all of that area. And then if this sailing boat, if he positioned himself in this corner, spiky bit there, he could do all of that area. Okay, so you've got a fairly decent coverage there. What about if we're up here? So we've got this boat here. He could do all of that area. And then if his mate's up here, spiky bit there, he could do all of that area. Who's winning so far with that one? Well, look at the overlap. The overlap's probably the key to this. Look at this massive size of the overlap there compared to the smaller size of the overlap there. Look how much space is left unoccupied there. Look how much space is left unoccupied there. I think this is your best option so far for the boats, but will this one beat it? Let's have a look. pencil's going a bit dodgy here, but I'm on my last video, so fingers crossed it'll survive. Spiky bit there. Let's have a look here. And we get that bit there. Now, I think we've got a clear winner here, right? Look at that, hardly any overlap at all, and not much space that's been left unoccupied. So what I'm going to write down here is this position is best. Oh, help if I could spell the word best. And I'm going to put because hardly any overlap and more of the area is covered. Dear me, my writing is getting worse and worse every single video. But there is a pretty decent explanation, I reckon, and a diagram of why this position of the boat, is the best one. And that concludes construction and loci.